Alright folks, at first many said that protein couldn't really be innovative, but luckily for us here at Glaxon, we already had a pretty solid idea. Whey protein isn't just for athletes, it's also in baby formula too, and along with the protein content, there's all sorts of other goodies that those babies get that help them grow. And quite frankly, this made us jealous. So buckle up for an in-depth breakdown on protein, ingredients in baby formula, and why we've chosen to include these things and the most humanized whey protein blend yet. Talking about Protos Whey on this episode of the Supplement Lab. And for those of you who don't know me, my name is Joey Savage. I'm the CSO here at Glaxon, and if you like this video, give me a like, a subscribe, and a follow. We're on Instagram and YouTube at Supplement Lab and Discord at Glaxon and the Supplement Lab Discord as well. So with this episode that does feature the use of protein, I'm going to spare you the central dogma of replication, transcription, and translation, and try to keep things fairly simple. So why exactly do we ingest protein? Well, we do it to essentially grow new tissue, which is also made of protein. It's just not the exact same proteins that we get in our food. So when we consume protein, most of the digestion of this stuff occurs in the stomach, where along with the help of stomach acid and water, these proteins are broken down into smaller peptides by enzymes called proteases. Now, these peptides are then further broken down into amino acids by enzymes called peptidases, and some of the peptides can actually be absorbed intact, but for the most part, the body really wants to break these things down into amino acids for all sorts of different reasons. Now, from what the experts tell us, that if you really want to keep your body in an anabolic state with better nitrogen retention so you can increase your endogenous amino acid synthesis, this actually requires somewhere in the neighborhood of 1.5 to 2.5 grams of protein per kilogram of body mass. So for simplicity's sake, let's say you're a 220-pound dude, which is conveniently 100 kilos. This means you're actually going to need to consume around 150 to 250 grams of protein per day to conserve and or build muscle mass. This could be in the form of, say, 6 to 10 protein shakes, or 3 to 6 8-ounce chicken breasts, or 25 to 42 eggs. Or if you really like to indulge, you can have 6 to 10 McDonald's double cheeseburgers. Or if you're the experimental type, maybe you'll get your hands on 240 to 400 milliliters of cockroach milk, which is actually less volume than a bottle of water. But the thing is, you're not supposed to get all of this protein exclusively from one source. It's supposed to be a variety of different sources and combinations of the total protein that you obtain from your diet. And whatever you don't consume there can be made up and consumed in the form of protein shakes. But unfortunately, this isn't the entire story. The journey that protein takes from being in your food to actually being in your muscles is actually a pretty long trip. These molecules have to pass through the stomach and the intestines and the liver and any other random tissues that might also need to undergo repair. Then, as this final act of the protein, they can finally get to the muscles where you actually want them. Let's just say even if your protein or amino acid absorption was 100%, it's actually speculated that only 50% of the ingested amount of protein or aminos actually gets into systemic circulation, where it causes a state known as hyperaminoacidemia, where it can actually get to your muscles. And of that 50%, it's estimated that a whopping 11%, or roughly 2.5 grams of protein for every 25-gram protein shake you consume, will even be able to partake in protein synthesis. So what factors come into play when shooting for optimal protein and amino acid absorption? Well, there's quality of protein. That would be first. Is this a complete protein that has all the essential amino acids necessary for triggering a muscle growth response? Then there's digestibility. What kind of protein is it? Does it digest quickly or slowly? This is the classic whey casein paradigm, where whey is able to be broken down and absorbed fairly quickly, whereas casein tends to curdle in stomach acid and it slows down its rate of digestion. Next is amino acid content. Are there amino acids present that might help facilitate your muscle growth? How much leucine is in it? Are there any other branched chain amino acids? And what is the rate of proteolysis in the body, or your protein breakdown, and can that even be slowed? Studies have shown that along with casein's slow digestibility, casein has a stronger impact on slowing down total muscle protein breakdown than whey does. And it's key to remember that overall protein synthesis doesn't necessarily equate to muscle protein synthesis. The mechanisms of protein synthesis aren't exclusive to muscles, but instead it's an event that's occurring on the level of the entire body. And it's a key function of every cell from your gut lining to your skin. And finally, there's the impact of insulin. Is this protein co-ingested with a source of carbohydrate or maybe anything else that can increase your insulin sensitivity? Because having active insulin absolutely plays a role when it comes to how much actual dietary protein your muscles get access to. Now let's talk about milk and why mammals love it so much. Now you're probably most familiar with cow's milk that you probably pour into your cereal or your coffee or a whole host of other different foods. Now, cow's milk differs from human milk in several ways. First of all, the proteins that are found in cow's milk are more casein dominant than in human milk, and human milk actually has a higher whey protein content. They actually contain similar amounts of fat. However, human milk contains more of the healthy unsaturated fats that are usually contained within milk fat globule membranes. Now, human milk also has a far higher amount of carbohydrates than cow's milk. But these are functional carbs. They are usually known as human milk oligosaccharides. And now that we know how these milks kind of differ from one another, let's do a quick comparison on whey versus casein. Whey protein digests quickly and it has a fast yet transient spike in its ability to increase blood amino acid levels. Another key fact about whey protein is that it's got a particularly high leucine content and it elicits a stronger insulin response, and therefore whey has a significant impact on the initiation of muscle protein synthesis. Now this differs from casein in that casein digests more slowly and causes a more gradual rise in hyperaminoacidemia, and casein is actually more amino acid dense, but it also has a slowing effect on muscle protein breakdown, an attribute that whey protein alone does not have. So in Protos Whey, we've decided to take what the cows have given us and adjust the protein ratios that mimic those that are found in human milk. There's some debate about what this whey to casein ratio in human milk actually is. Some say it's as high as 80% whey to 20% casein, or as low as 60% whey to 40% casein, but we've chosen to split the difference here with a 70% whey to 30% casein ratio, which has recently had some clinical findings that we found to be pretty encouraging. In clinical studies investigating the 70-30 whey casein ratio, it was discovered that it's got a significant impact on the perception of DOMS, or delayed onset muscle soreness. It causes about a 44% greater insulin response than regular milk, where this ratio is inverted. It caused a 96% increase in glucagon-like peptide 1 activity, which supports better insulin sensitivity. Blood amino acid levels showed up at a rate of about 70% at 60 minutes post-ingestion, and 110% rate of appearance at about 90 minutes. Now this is important considering that the window of opportunity for getting amino acids to hungry muscle tissues is essentially open for roughly 120 minutes post-exercise. Just this whey casein protein ratio alone is what sets the stage for making a protein blend that comes from cows and makes it look more human. So in addition to this, what else have we done? Well, if you've been paying attention, I briefly touched on something called milk fat globule membrane, which is a fairly new ingredient to the sports nutrition protein category. However, it's not new to baby formula, which is where we got this idea. Now, milk fat globule membrane, or MFGM, is a pretty complex collection of different molecules. In human milk, MFGM is there for several developmental reasons. It supports brain structure and function, intestinal development, and participates in immune defense to a degree. It contains phospholipids, glycolipids, glycoproteins, and carbohydrates in addition to actual protein. But perhaps the most compelling data in the literature showed that actual middle-aged adults using supplemental MFGM over a 4-week period with resistance training had a statistically significant increase in muscle strength over the placebo group with no increase in overall muscle mass, which was kind of a perplexing finding. How can you increase strength without adding on extra size? Aside from the worlds of hypertrophy, where your muscle cells are just increasing in size, and hyperplasia, where they're simply increasing in number, a third factor is involved in how well the body can be utilized to do work, and that's neurological. I've spoken a great deal about the mind-muscle connection and how acetylcholine is pretty much the neurotransmitter that rules this domain. But the authors of the MFGM study hypothesized that due to the phospholipids that are contained in MFGM, that phosphatidylcholine could be working as a potential acetylcholine precursor. But also in addition to this, MFGM contains something called sphingomyelin, which is a crucial component of the myelin sheaths that surround the long parts of the axons of neurons, and they can also increase the rate at which the electrical impulses are fired across the neuromuscular junction, the place where your nervous system and skeletal muscle system actually communicate. The investigators further explained that it's possible that some additional recruitment of motor neurons may have occurred, and this could have easily improved the mind-muscle connection and resulted in what appeared to be a boost in muscle strength. Along with the addition of these functional fats in Protos Whey, we've decided to incorporate another component of human milk, and that's human milk oligosaccharides, or HMOs. HMOs are perhaps the most abundant compounds that are found in human milk. There's over 2 different kinds of human milk oligosaccharides that are known, and approximately 80% of the total HMOs found in human milk are a specific kind, known as 2-FL or 2-fucosylactose lactose. Now, 2-FL acts as a prebiotic in the gut, and it feeds bifidobacteria species, which are known for fermenting these kinds of sugars into small-chain fatty acids like butyrate, which have beneficial effects on gut health and overall growth in general. Now, similar to MFGM, 2-FL has some metabolites like sialic acid that are essential nutrients for brain development. Additionally, these HMOs can also benefit innate immunity. These specialized carbohydrates can reduce your risk of infection by actually binding themselves to foreign pathogens, kind of gumming them up and preventing them from gaining access to your body's tissues. Another characteristic that is also shared with MFGM. Now, there's also a bit of carbs and chromium that come from the patented Velocital blend and Protos Whey. Historically, Velocital usage has been used in reference to the consumption of Velocital in combination with subpar amounts of whey protein, showing that this combination can actually outperform whey protein at about double the dose of the subpar combination in terms of increasing muscle protein synthesis. So over a 15 and 30 gram dose of whey protein alone, 15 grams of whey protein plus Velocital resulted in better insulin responses, higher amino acid absorption, higher rates of muscle protein synthesis, more squat reps to failure, a higher vertical jump, higher net protein balance, and slightly decreased blood pressure after 4 weeks of use. Now, logic would lead us to believe that, hey, there's some moderately glycemic carbs here at a fairly low dose. This then combined with a very healthy dose of actually 2 forms of chromium, so one could logically conclude that we might see some better insulin sensitivity here, and when this is combined with whey protein or amino acids, shocker, we're going to get higher rates of protein synthesis. Now, while all that is good and fine, it certainly begs the question, well, what does Velocital do with an optimal dose of whey protein? Now, I'm about to show you a chart that isn't in the public literature. In fact, the only time that you might have even seen this would likely be at like some sort of a sports nutrition research conference or some other place where Nutrition 21 might have been making a presentation. With a disclaimer that this is part of preclinical research that was done by Nutrition 21 on Velocital in combination with varying dosages of whey protein compared to whey protein alone, we see this. And what's surprising is from the onset of looking at this chart, that just a 6 gram dose of whey protein plus Velocital with exercise actually outperforms 20 gram dose of whey protein alone. But what if that 20 gram dose had Velocital with it? It turns out that apparently that's the sweet spot for Velocital, and if you take a look at the rest of this chart, you're going to see that 20 grams of whey protein plus Velocital can actually yield better results in terms of muscle protein synthesis than a 30 gram dose or even a 40 gram dose of whey protein alone. In fact, if you were to actually add Velocital to the 30 and the 40 gram dose of whey protein, the extra boost in protein synthesis that you would get on top of that would only be marginally better than the 20 gram dose of whey protein when combined with Velocital. Meaning that at some point between 20 and 30 grams of whey protein, Velocital starts to have a little bit of diminishing returns. But Protos Whey also has prohydrolase digestive enzymes. Now, these are proteases that help facilitate protein breakdown in the gut, not only decreasing the overall stress on your gastrointestinal tract, but also speeding up the process of obtaining hyperaminoacidemia by getting amino acids into circulation within about 30 minutes, making the most of your anabolic window post-workout. Other things that you're going to find in Protos Whey that aren't too obvious would be the fact that we also happen to feature a hydrolyzed form of casein known as PeptoPro, which actually absorbs so quickly that the body's organ systems hardly have a chance to even claim any of these peptides as their own, and thus increases how much is available to your muscles. There are also several casein fragments that have wide-ranging effects on the body, from the ability to decrease blood pressure like you see in Vasodrive AP, to helping your body metabolize sugars like you see in the Pep2D that we have in Xerion. There's also lactose-free whole milk powder in Protos, because I'm a firm believer in always mixing with milk, and since I can't bank on everyone having milk in their fridge, we've included it in powder form that amplifies texture, taste, and mouthfeel. And Protos Whey is available in 3 awesome flavors as part of our milk series. Our traditional chocolate milk, our fantastic strawberry milk, and our take on the remaining milk after dunking a bunch of cookies in milk. So that's our show for today. It's Glaxon's take on innovating the old category of whey protein blends designed to help your weary muscles recover, get stronger, and provide further benefits to the body as a whole. And we've done all of this while striving to make something that comes from a cow seem a little more human. I'm Joey Savage, and this has been Protos Whey, and we will see you next time on the Supplement Lab.